Welcome dear students to IUPAC Nomenclature of Aldehydes and ketones. Aldehydes is a class of organic compounds having formyl functional group, and ketones is the class of the organic compounds having keto group as the functional group. And both these in IUPAC system are considered as the derivatives of alkanes. So the parent name of any aldehyde is derived from the alkanes by replacing the E of the alkane with Al. All the aldehydes, they have parent name as alkanals, and the parent name of the ketones, again it is derived from the alkanes by replacing the E of the alkane with ONE, and in IUPAC system the parent name of all the ketones is alkenon. Now, my dear students, in case of simple aldehydes and simple ketones, you can derive their names from the corresponding alkanes by replacing the E with Al or by replacing the E with ONE. Just like it is a simple aldehyde in front of you having only one carbon atom. So the alkane having one carbon atom is called as methane, and its IUPAC name should be, from methane it should be methanol. Similarly, this one is a simple aldehyde with two carbon atoms, and from its corresponding ethane, it should be named as ethanol. In the same way, this one is an aldehyde having three carbon atoms, and the corresponding alkane which has three carbon atoms is called as propane, so it should be called as propanol. In case of aldehydes, a very important point, my dear students, listen carefully. In case of aldehydes, there is no need to mention the location of the functional group. Just like in case of alcohols or in case of any other class, we mention the location of the functional group. So there is no need to mention the location of functional group in case of aldehydes. Why? Because the functional group is always present at the terminal of the chain, and the carbon of the functional group always gets number 1 in the numbering. So in case of simple aldehydes, you can name them from their corresponding alkanes by replacing E with Al. Similarly, in case of simple ketones, just like this one is the simplest ketone because the ketones they start from 3 carbons. So that will have a name from 3 carbon alkane, propane, and you will replace the E of the propane with ONE, and that will be called as propanone. In the same way, it has 4 carbon atoms, so it will be called as butanone. Up to the ketone having 4 carbon atoms, there is no need to write down the position of the functional group, because in both these the position of functional group will remain fixed, and that will be on the carbon number 2. Just like this carbon will always remain carbon 2 in propanone, and this carbon will always remain carbon number 2 in case of the butanone. But in higher ketones, then we have to mention the position of the functional group. So it is very simple to name the aldehydes which have a carbon number up to 3, and in case of simple ketones, again the IUPAC nomenclature is very simple. But if an aldehyde or ketone gets complex, then these are the steps that we will have to follow while naming the aldehydes or ketones. The first will be the selection of the continuous longest chain of the carbon atoms, that will be called as the parent chain, or you can say main chain or skeletal chain. And the parent chain has 3 characteristic features. It has maximum number of carbon atoms, it has all the alpha carbons inside it, and it has maximum number of substituents attached to it. And this parent name will give the parent name to any alkane or aldehyde or ketone. Now the second step will be numbering. In case of aldehydes, you will start the numbering from the end where the aldehyde group is attached. That is very simple. But in case of ketones, you will begin the numbering from the end of the chain where you will find the functional group nearer. But if the functional group is present at equal distance from both sides of the chain, then you will look for the substituents. You will start numbering from that end of the chain where the substituent is nearer. But if the functional group and substituent both are present at the equal distance, then you can start numbering from any side of the chain. After numbering, then we will name, And while writing down the name, first of all, we will mention the location of the substituent by writing down the number of carbon atom to which that substituent is attached. If the same substituents are there, prefixes di, tri, tetra will be used. If the substituents are different, then we will name them alphabetically. In case of aldehydes, there is no need to mention the location of the functional group as it is always present at the terminal. That is why the aldehydes do not show the position isomerism. But in case of ketones, you will mention the position of the functional group by writing down the number of the carbonyl carbon. And then the parent name will be given. In case of aldehydes, that will be alkenyl, and in case of ketones, that will be alkenones. Now let us name some complex aldehydes and ketones, just like this one. In case of this aldehyde, the parent chain can be 1, 2, 3, 4. It can be a straight chain, or 1, 2, 3, 4. It can be a chain like this. So you can select any of them as the parent chain. This is the parent chain. Now, in case of this, my dear students, 1, 2, 3, 4, 5, straight chain has 5 carbon atoms, but there is another chain which may be longer as compared to the straight chain 1, 2, 3, 4, 5, 6. This chain has 6 carbon atoms, so it is the longest chain that will be considered as the parent chain. Now, first of all, let us name these two aldehydes. My dear students, after selection of the parent chain, the next step is the numbering. The numbering always starts from the carbon of the formyl group in case of aldehydes 1, 2, 3, and 4. And similarly 1, 2, 3, 4, 5, and 6. After numbering, now let us name them. First of all, the location of the substituent will be mentioned. The substituent is methyl group, which is attached to carbon number 3. So its location is 3. The name of substituent is methyl, and as there are 4 carbon atoms, so its parent name should be butanol. So it will be 3-methyl butanol. In this case, there are 2 methyl groups which are present on the same carbon atom, so its position, their position will be mentioned by repeating the number of that carbon. We will write it down 4, 4. There are 2 methyl groups. In case of same substituents, we use the prefixes. So that will be dimethyl. And now it has 6 carbon atoms. So the parent name should be hexanol. Now, my dear students, look at this name. We have used some punctuation marks in this name. According to the recommendations of the IUPAC, between two numbers, you will mention a comma. Between a number and word, you will mention a hyphen, and between two words, you will use no punctuation mark. So that is why between these two numbers, I have used a comma here. Between a number and a word, I have used a hyphen here, and between two words, I have used no punctuation mark. So you will also keep in mind that the punctuation of the organic compound or the name of the organic compound, that should be accurate. In case the organic compound, the name of the organic compound is correct, but the punctuation is incorrect, the whole name will be considered as incorrect one. No, this one is, it is an aromatic aldehyde. So from benzene, it should be called as benzaldehyde. But my dear students, keep one thing in your mind, that it is the common name of this aromatic aldehyde. Aromatic aldehydes are not given the IUPAC names. They do not have IUPAC names. Now let us move towards the ketone. This one is a ketone with 5 carbon atoms. First of all, select the longest chain, that will be the straight chain. Now allot the numbers. As the functional group is nearer to this end of the chain, so you will start the numbering from the side where the carbon of the functional group gets the lowest possible number. So that should be the numbering. Now similarly, in case of this ketone, again the straight chain will be the parent chain, and the functional group is present in exact mid of the chain. So you can start numbering from any side of the chain. In this case, my dear students, again the straight chain, it will be the parent chain, or you may also select as this chain as the parent chain. But let us keep the things simple and we will select the straight chain as the parent chain. Now we will start the numbering from the side where the functional group is nearer, or we will start the numbering from the side where the carbon of the functional group gets the lowest possible numbers. My dear students, in this example, the functional group is again in the exact mid of this chain. So can we start the numbering from any side? No. When the functional group is at equal distance from both sides of the chain, then the next is that we will look for the substituent. The side having the substituent nearer to it, that will be the exact side from where the numbering will start. Now, starting from this side, this substituent is present at 1, 2, 3, 4, fourth carbon. But from this side, this substituent is present at second carbon. It means this is the side from where the substituent is nearer. So we will start numbering from this side of the chain where the substituent is nearer. You cannot start numbering from this side because the substituent will be far away from this side. So the rule is that first of all look for the functional group. If the functional group is at equal distance, then look for the substituent and start the numbering from the side where the substituent gets nearer. Similarly, these are two aromatic ketones. We will name them after some time. First of all, let us name these aliphatic ketones. Now, what should be the name of this ketone? There is no substituent. You will just mention the location of the functional group by writing down the number allotted to the carbon of the carbonyl group. It is 2, and there are 5 carbons, so that will be pentanone. From pentane, that will be pentanone. In this case, the carbon of the carbonyl group has 3, location is 3, so that will be pentanone. The 2 pentanone and 3 pentanone, they have same molecular formula, but they have different position of their functional group, so they are called as the position isomers of each other. In case of this ketone, it has a substituent. So first of all, write down the location of the substituent. It is 2. The name of substituent is methyl. The location of functional group is 3, and then that will be called as pentanone. So this should be the name of this ketone. Now these are two aromatic ketones, and aromatic ketones do not have IUPAC names, just like the aldehydes. Aromatic aldehydes and aromatic ketones are not given the IUPAC names. It will be acetophenone. This one is the part of the acetone, so it is aceto. This one is a phenyl group, so it is phen, and the suffix for the ketones is ONE, so it will be acetophenone. Now this should be benzophenone because this is benzo. Again, phen, this one is the phenyl group, and keto group has the suffix ONE, so that will be called as the benzophenone. So in this way, you can name any aldehyde or ketone. In case of simple aldehydes and ketones, there is no problem, but the problem comes when you will say some complex aldehyde or some complex compound, then you will have to follow these rules. So it was all about the IUPAC nomenclature of aldehydes and ketones. You will have to practice some more questions at your home, and if you will find any problem while naming the aldehydes and ketones, you can consult with me through comments. I will definitely answer you. Till then, take care.